Imagine a moment so powerful it created everything we know, from the smallest atom to the vast expanse of the universe. This was the Big Bang, a theory that stands as the leading explanation for the origin of the universe. You see, everything we see, touch, and experience, all the stars in the night sky, the planets, galaxies, and even the space between them, sprang into existence from a point of infinite density and temperature. This was the initial singularity. Picture an explosion so immense, so cataclysmic, that it didn't just create matter and energy, but space and time itself. This was not an explosion in space, but rather an explosion of space. A mind-bending concept, isn't it? And in that moment, the universe as we know it was born. So, in the blink of an eye, the universe went from a point of infinite density to an ever-expanding cosmos. Now, picture the universe in the moments after the Big Bang, an extremely hot, dense state expanding rapidly. Imagine it's like a cosmic soup, a hot, dense mix of subatomic particles, rapidly cooling and expanding. This was a time when the universe was so hot and dense that atoms couldn't form yet. As the universe expanded, it cooled down, and protons and neutrons started to come together to form the first atoms, primarily hydrogen and helium. These atoms started clumping together under the force of gravity to form the first stars and galaxies, lighting up the universe in a blaze of creation. This cosmic dawn is a pivotal moment in our universe's history. One of the most compelling pieces of evidence for the Big Bang is the cosmic microwave background radiation. This radiation is like the afterglow of the Big Bang, a faint echo of light that permeates the entire universe. As the universe cooled and expanded, the first building blocks of life began to take shape. But how do we know all this happened, you might ask? Well, the Big Bang theory, like any good theory, is supported by a wealth of evidence. The first striking piece of evidence is the observed redshift of distant galaxies. This is essentially a shift in the color of light from galaxies moving away from us, towards the red end of the spectrum. This redshift is a compelling hint that the universe is expanding, just as the Big Bang theory predicts. And there's more. The existence of the cosmic microwave background radiation, or CMBR, is another crucial piece of the puzzle. This radiation is a relic from the early universe, a snapshot of the cosmos just a few 100,000 years after the Bang itself. It is uniformly spread throughout the universe, again supporting the Big Bang model. These observations give us a window into the past, allowing us to piece together the story of our universe's birth. Our universe has come a long way since that initial explosion. Today, it's a vast cosmic expanse, studded with galaxies, stars, and planets, all born out of that initial spark. The universe continues to expand, a phenomenon driven by a mysterious force known as dark energy. This invisible energy, although not fully understood, is believed to counteract the force of gravity and cause the universe to expand at an accelerated rate. Our understanding of the Big Bang theory also offers a glimpse into the future. Scientists predict that the universe will continue expanding indefinitely, gradually cooling and diluting. Over trillions of years, stars will exhaust their nuclear fuel, galaxies will drift apart, and the universe will transition into a state of darkness, a far cry from the hot, dense state it once was. From a point of infinite density to the vast, ever-expanding cosmos we call home, the Big Bang theory gives us a fascinating glimpse into the origin and evolution of our universe.